loop. Why? Because that's where the value of the iterator changes, right? So no matter what the value it has at the beginning of the program, when it hits this loop, because this loop says do n equal to 1 to and number of iteration, and the value changes to 1. So that's why it stops there, right? And for the one as a stop at the breakpoint, so this is the breakpoint that we for the processes, right? We said for a subset of the processes. So actually, I'm not quite sure why those processes show a stopped status. It should show a break. It should be a breakpoint, because if you look at these rank 0, 2, and 4, and 6, all of them are stopped now at the breakpoint we set. So I'm not sure why it shows a T instead of a B. Okay, but anyways, this is the way you set action points with TotalView, and says set where the breakpoint is, and set the scope of various action points. Okay. Any question? All right, so cover this. All right, now the next step would be to view or edit your data. So it's just to manage the data, right? So for debugger, it's kind of again, it's a common feature for most debuggers. Okay. So now let's see if we can get all the processes run to the same place. Let's see here. Let's get a breakpoint. So you can click on the action points in the window to disable it. It's not remove it, just to disable it. When it turns gray, it means it's disabled. Okay, can enable it later on, but now let's just disable everything and let everybody stop. So if you check the status, now everybody has a breakpoint. And actually, if you click on that little plus sign there, it tells you on which breakpoint it is at. Okay. Okay. Now, remember in this stack frame sub-window, that's where we have all the variables, local variables. Okay. Now, if you click on any of the variable here, a variable window will pop up. Okay, so what I did is double click on n, and now I have a variable window for n. Okay, so now the value, it shows expression of the variable and the address in the memory and the type of the variable and also the value of it. Okay, so now n is 1 for this for this process. Okay. So for a parallel program, you might want to see, what the value of a certain variable is across all the processes. Okay, so what you do is click on View, and then Show Across Processes. Okay, and apparently these two guys. So you see, this is a process, and this is a rank MPI rank of it 0 through 7, and the value of it. So apparently there are two guys that are still hanging back there somewhere. Not sure what they're doing. Let's see if we can get it to the same.
Leon? Can you point people at the exercises to help them step through this and do this on their own? I think people need some time to actually play with this.
Oh, okay. Exercise. Well, if I open that web page, all the programs are there, and actually, if you go to the towards the end of this, toward the end of the slides, there's a description of the problem. What this? Well, yeah, I probably should have gone through this first. So actually, this is what the program tries to do. Actually, it's kind of like, it's kind of a silly, it's meaningless. So, but it tries to do a one-dimensional finite difference thing. So you have a one-dimensional periodic array and with number of elements in it, and well, you can give it so it has initial value. Okay, and so basically what the program does is to go through a loop. So at each iteration, update each element using the value of the neighbors. Okay, the only thing is this array is periodic. Okay, so basically you need to for this element here as the very end, as for the leftmost element, it needs this element as well as this. Okay. So, and just go through the loop, and finally, try to find some, global property, like the average or global maximum of this array. Okay. So, for sequential program, it's kind of simple, right? They have an array, and they have another array to hold, array hold the current value, and another array to hold the calculated value. Okay. So what you do is just update the value in one array, and then swap the pointer. So and keep going. So for MPI program, so each process will of course grab a subsection of this array. So basically the data, it's like a ring topology, right? So each process needs to change values with its neighbors. Okay. So this is the application. This is the MPI version. And for the OpenMP version, of course, you put this array in the shared part of the memory, and then each thread can work on their own part. Okay, so there's no need to exchange data. So this is basically what what this exercise problem tries to do. So the program trying to run here is the MPI version. Okay, so yeah, I guess I think I have a few things left to show, and I think after that you're welcome to just use either the program provided on this web page, or you can use the program Rebecca just posted the Laplacian.c, because now probably just need a code in the program to play with. Because yeah, I know that just seeing me point here and there is probably not that impressive, I guess.
Yeah, maybe we need to let people just start playing with it to get a feel for it themselves. And I should add, I believe that TotalView is running on Big Red, Kraken, Steel, and Queen Bee, but I think those are the only systems that have TotalView today.
Yeah, so if you go to that web page, actually here's a list of the Kraken, Big Red, Steel, and Queen Bee. So here's I couldn't find the instruction for running TotalView on Steel, but the Kraken, Big Red, and Queen Bee, there's a link. If you click on any of them, so if you click on say Kraken, it will take you to the TotalView description, and the TotalView page at next. and this here's detailed instruction on how to run it. But it's just I'm not sure how many people have account on Kraken, Big Red, and Queen Bee, because there might not be enough for everybody to just to start a session. So that's why I just thought that I might just demo the usage.
UCLA has a question.
Yeah, go ahead.
I mean, we were allotted Ranger and Steel. We could get access only to Ranger so far, and you said TotalView is available only on Steel, and
not only on Steel.
No, I mean, at UCLA site.
Machines, yes.
Yeah, at UCLA site we were given. Yeah, I mean,
I never used a Steel before, so if I'm not sure if there's anybody from Purdue can help us out. I mean, like.
Yes, we need help from somebody from Purdue to access to Steel machine, because our SSH command to Purdue doesn't work. Even going through the portal did not work. But we could use the Purdue user account and password to log into the portal, but not to the machine itself. So if we could directly SSH to Purdue machines, we can do exercise at UCLA.
Well, I'm not sure if Scott can find somebody right now. I mean, to help folks at UCLA. And
we will send out a request, but I didn't realize you couldn't get on the machine yet. As soon as we're done here, let's figure this out and get a solution for you right away.
Thanks, Scott.
Send me an email, please.
Yeah.
Okay, so guess I'll just show a few other features of TotalView, and then I mean, hopefully everybody can get a session running by then, and Okay, so back to variable window. Okay, so basically you can double click on any variable. Okay, just to bring out this variable window, and then you can check the value of individual variable. Also, like what I just did, you can check the value of that variable across all processes. Okay, and also if you're trying to view the content of an array. Okay, so let's close this, and like I just described, what the problem is. We have this array that we keep updating in each iteration, right? So this is called buffer in this program. Okay, so you can either double click on it, as I mentioned, or you can just right click on it, and then there's the option called dive. Okay, this is a term that TotalView use, I think, exclusively. It's like open object. I'm not sure why they call it dive, but this is what they mean. Okay, so now you dive on this variable. Now this is buffer. It's like I said, it's just an array that holds the values of that we're interested. So now, okay, in the stack frame, we see this is it's just an integer array, and it has 102 elements. Okay, so if you dive on it, now all 102 elements are shown here. Okay, now